So yesterday we have completed the ideal solutions. What are ideal solutions? Ideal solutions are those solutions which obey Rolle's law under all constitutions. Now, what are the conditions to be satisfied for a solution to be ideal? It must obey Rolle's law. It must have enthalpy of atomization will be 0. Sorry, enthalpy of mixing should be equal to 0. Then enthalpy, so there should be any volume change during mixing. So enthalpy of mixing should be 0 and volume change during mixing must be equal to 0. Then it must obey Rolle's law. These are the conditions to be satisfied for a solution mixture to be ideal. Now when we are going to non-ideal solutions. So what are non-ideal solutions? Yesterday I told you non-ideal solutions do not obey the Rolle's law. That is, PA should not be equal to P naught A into XA and PB will not be equal to P naught B into XB and P total P will not be equal to, it will not be equal to PA plus PB. PA plus PB. The total pressure should not be equal to PA plus P. Then delta H mixing, that is enthalpy change during mixing, will not be equal to 0 and delta V mixing will not be equal to 0. So for non-ideal solutions this will be there. Now we will come to different types of non-ideal solution. One type of non-ideal solution is ideal solution which show positive deviation. Now what is positive deviation? See, suppose I am mixing ethanol and N-hexane. Ethanol and N-hexane. N-hexane is normal hexane. Ethanol is C2H5OH, ethanol. Between ethanol molecules, there is intermolecular hydrogen bonding. That is C2H5OH, then O, C2H5H, O, C2H5H, like this. There is intermolecular hydrogen bonding. Now this due to intermolecular hydrogen bonding, the interactive force between ethane molecule is very strong. Now when you add N-hexane, between N-hexane there is only weak van der Waals force of attraction. When you add, so A interactive force is very strong and BB interactive force weak. Now we add N-hexane to ethanol. Then what happens is this interactive bond, the hydrogen bond breaks and N-hexane molecules enter in between the ethanol molecules. So ethanol, the N-hexane molecules will enter in between these two and new interactive force come in between ethanol and N-hexane. It is only non-polar and weak dispersion force. So that is weaker than the AA, that is interactive force between ethanol molecules. So what will happen to the vapor pressure of ethanol? Rate of evaporation will increase, the vapor pressure also will increase. So this is not the change we expect. We expect that the ethanol will, the vapor pressure of ethanol will not change that much. Ethanol vapor pressure of N-hexane will not change. So the resultant mixture will have as we expect, but this is not what we expect. The rate of evaporation will increase, increasing the vapor pressure. Now for such type of solutions, that is if the AB interactive force is weaker than AA and BB interactive force, then what happens is the rate of evaporation will increase, vapor pressure will increase. Now if you plot a graph, what is our ideal solution graph is Rolle's law. We take XA is equal to 1 and XB is equal to 0 for ethanol. This is P naught A. Then when we add N-hexane, then this is what we expect. Then this is N-hexane, HB is equal to XB is equal to 1 and XA is equal to 0. Then this is the ideal. This is the ideal solution, and this is PA, this is PB, and this will be PA plus PB. This is the ideal. That is what we expect. Now what happens is the vapor pressure will increase. Instead of this we will get a curve like this. Instead of this we will get a curve like this. See how we are getting a curve. We will get a curve like this. We will get a curve like this. So instead of this one, we are getting a new curve. The vapor pressure will increase. The dotted line will show you what we expect. Now this is what we are getting. So this will be PA, this will be PB, and this will be PA plus PB. So this is what we get. Instead of getting this one, instead of getting this graph, this broken line graph, we are getting this one. So what happens? The vapor pressure is higher than what we expect. Now you see a solution here. This solution where here this is a point where it forms an azeotrope, that is ethanol and hexane, or another ethanol and hexane is one example. Ethanol and hexane is one example which shows such type of positive deviation, or ethanol water, another. Between water molecules there is strong hydrogen bonding, much stronger than that ethanol. So when you add ethanol to water, what happens? The strong hydrogen bonding between water will break away, and between water and ethanol a hydrogen bonding is formed which is much weaker than the hydrogen bonding between water molecules. That means AB interactive force is weaker than AA interactive and BB interactive force. Therefore what happens is the rate of evaporation will increase. Such solutions will show a positive deviation. Now here you see the composition in liquid and in vapor phase. The composition of this mixture will be same. See, when you suppose you are boiling a mixture of ethanol and alcohol, we have studied distillation. What happens? Ethanol, which has a lower boiling point, will distill out first, isn't it? That's what we have studied in our lower classes. Now, when this is the composition, as well as in liquid and in vapor phase, the composition will be same. Suppose it is 95% alcohol. 95% alcohol, when you distill it, in the vapor phase also it will be 95% only. The remaining 5% will be water. That means in liquid phase and in vapor phase they have same composition. Such type of mixtures are called azeotropes. Azeotropes are mixtures which have same composition in liquid phase as well as in vapor phase. So here you see this at this composition, this mixture ethanol water or ethanol and hexane, they form an azeotrope. For ethanol water it is 95% alcohol, that is 95% alcohol and 5% water. Even in you distill it, after distillation also you will get only 95% alcohol and 5% water. That's why we say that by distillation you cannot produce pure, that is 100% alcohol, absolute alcohol you cannot prepare by distillation, because distillation means at 95% they will form an azeotrope. That means beyond that you cannot purify them by simple distillation. By simple distillation you can purify them up to 95%, because 95% alcohol it is an azeotrope. So even in vapor phase it will be 95% alcohol only. So when you distill an alcohol water mixture, what you are getting is only 95% alcohol, not absolute alcohol. That alcohol also contains some water. The distilled product also will contain some water. That is 5% it will be water and 95% it will be ethanol. So this is an azeotrope. Azeotrope is a mixture which has the same composition in liquid phase as well as in the vapor phase. Now this is what we expect, that this is vapor pressure. So this is vapor pressure. So this is the vapor pressure of that mixture, what we expect, but actually this is it, isn't it? So higher than this one. That means vapor pressure is high. What about its boiling point? If vapor pressure is high, the boiling point will be low. Now we have studied that vapor pressure is, boiling point is the temperature at which vapor pressure will be equal to surrounding pressure. If vapor pressure is high, then to make it to equal to surrounding pressure, we need only a little bit rise in temperature. So such liquids will boil fast. So alcohol, its boiling point is nearly 60 degree. Why? Because its vapor pressure is very high, rate of evaporation is very high, so boiling point will be low. For water, the intermolecular force of attraction is very strong, so rate of evaporation is less, vapor pressure is low, therefore boiling point is high. So here, as we expect, this will be the vapor pressure, but this is the vapor pressure. Vapor pressure is higher, so the boiling point will be low. So we call such azeotropes as minimum boiling azeotrope. They are called minimum boiling azeotrope. So what are minimum boiling azeotropes? Azeotropes which has a lower boiling point, they are called the minimum boiling azeotrope, and solutions which show positive deviation from ideal behavior. That ideal behavior, they perform this type of minimum boiling azeotrope. Okay. So what is positive deviation? Positive deviation from ideal behavior. That is, for example, ethanol, N-hexane, ethanol, water, etc. Here the AA interactive forces and BB interactive force and AB interactive force, if you compare, the AB interactive force is much weaker than AA and BB interactive force. So in ethanol and hexane, between ethanol molecules there is hydrogen bonding. Between hexane and hexane there is only weak van der Waals forces. If you add N-hexane to ethanol, the hydrogen bonding between ethanol will break and N-hexane molecules will enter in between. So now the new interactive force formed is between ethanol and N-hexane, which is weaker. So the rate of evaporation will increase. Ethanol water, between water molecules there is strong hydrogen bonding. When you add ethanol, what happens is that strong hydrogen bonding between water molecules will break and ethanol molecules will come in between. And the hydrogen bonding is formed between ethanol and water molecules, that is much weaker. Therefore, the rate of evaporation will decrease and the vapor pressure will increase. So, as we expect, PA will not be equal to P naught A into XA and PB will not be equal to P naught B into XB. And what happens to the enthalpy of mixing? See, its weaker interactive force is formed. Already there was a stronger interactive force, so a lot of heat energy is required for breaking that interactive force. Only a weaker interactive force is formed, so that what does that mean? It means a lower energy only is produced. That means energy required to break the bond was higher and energy released during the new interactive force is low. So delta H will be positive. Heat energy will be absorbed. So delta H is not 0. Delta H mixing will not be equal to 0. Now what about delta V mixing? See here, there is a hydrogen bonding between ethanol molecules or between water molecules which is keeping them closer. When N-hexane is added, the molecules will break away, isn't it? They will move away so that N-hexane can enter in between. So what that means is the molecules fall apart. The molecules fall apart. Therefore what happens? The volume will increase. The volume will increase. Therefore delta V mixing will not be equal to 0. Delta V mixing will not be equal to 0. So all the conditions to be satisfied for a solution to be ideal is not shown by this mixture. Therefore this is a non-ideal solution, and non-ideal solution with a positive deviation, and such solutions will form azeotrope. What type of azeotrope? As minimum boiling azeotrope, because their expected vapor pressure is high. Therefore if vapor pressure is high, boiling point will be low. That is why they are called low boiling azeotropes. Now you take chloroform and acetone. Acetone and chloroform. Between chloroform and acetone, between chloroform molecules, there is no much stronger interactive force. Between acetone also, the interactive force is weak. But when you add an acetone or mix acetone and chloroform, you see chloroform is Cl3, and acetone is C double bond O CH3. Between hydrogen of the chloroform and oxygen of acetone, a hydrogen bonding is formed. So between chloroform molecules there is only weak bonding, weak interactive force. Between acetone molecule also there is only weak interactive force. But when we mix them, a hydrogen bonding is formed between these two. That means the new interactive force is stronger. The new interactive force is stronger. Therefore, what happens is the AB interactive force is much stronger than AA or BB interactive force. That means the rate of evaporation will decrease. When rate of evaporation decreases, vapor pressure will decrease. Okay? Vapor pressure will decrease. So, what we expect and what we are getting, they are different. So, if you plot a graph, again, if you plot a graph like this is XA is equal to 1 and X, you can take either XA and B. XB is equal to 1 and XA is equal to 0. So, if this is what we expect, the ideal solution. So XA is equal to 1 and XB is equal to 0, and this is what we expect. This is our ideal solution, what we expect. Now what happens is when a new interactive force is formed, vapor pressure will decrease. So what we get is like this. A curve like this you will get, and this is XA, so PA, this is PB, and this is PA plus PB. So we will get a graph like this. This is the ideal. Dotted line shows the ideal solution, and this is what we are getting. And here also see an azeotrope is formed. And this composition, an azeotrope is formed. Now this azeotrope, this is what we expect. The vapor pressure, but only this much is there. So that means the vapor pressure is lower than what we expect. Lower boiling point, lower vapor pressure, so boiling point will be higher. So this type of azeotrope is called a maximum boiling azeotrope. It is called a maximum boiling azeotrope. So two types of azeotropes are there, minimum boiling and maximum boiling. So here the solutions with a negative deviation they show this, they form this type of azeotrope, that is maximum boiling azeotrope. So what is negative deviation? So if the new interactive force, that is AB interactive force, is much stronger than AA or BB interactive force, then what happens is this, they form a hydrogen bonding, so rate of evaporation will decrease. Rate of evaporation, when it decreases, what happens? Vapor pressure will decrease. So vapor pressure decreases. It's not as what we expect. The vapor pressure is decreasing. So when vapor pressure decreases, what happens? We will get a mixture with a negative deviation. Now they also form azeotrope. Azeotrope means constant boiling mixtures, or mixtures where the composition is same in liquid as well as in vapor state. So you are getting an azeotrope. Here it has a lower vapor pressure, so boiling point will be higher. So it is called a maximum boiling azeotrope. So this is what is negative deviation. So for example, it is chloroform and acetone is an example of the solution with a negative deviation. Okay, so these are negative deviations. Now, so we have seen, and these are the two types of deviations from ideal behavior. That is, those show positive deviation, and those show negative deviation. Those show positive deviation, that the new interactive force will be weaker than the old two interactive forces, so the rate of evaporation will increase and vapor pressure will increase. And for example is ethanol water mixture, ethanol and hexane mixture, etc. There we get an azeotrope which has constant boiling mixture which has a same composition in liquid phase as well as in vapor phase. Then this is having a, since it is vapor pressure is higher, boiling point will be low, so it is called a minimum boiling azeotrope. Now another example is this one with a negative deviation. Now in negative deviation, what happens? The new interactive force, that is AB interactive force, is stronger than AA or BB interactive force, so the rate of evaporation decreases. When rate of evaporation decreases, vapor pressure will decrease, and we are getting such a mixture with a negative deviation. There, since the vapor pressure is low, its boiling point will be high, so it is called a maximum boiling azeotrope. So PA will not be equal to P naught A into XA, and PB will not be equal to P naught B into XB. Then what about delta H mixing? Here a lot of energy is released when new interactive force is formed because it is stronger one, isn't it? So since a stronger interactive force is formed, higher amount of energy is released. To break the old bonds, it requires only less amount of energy. So the delta H will be negative. കുറച്ച് എനർജി കൊണ്ട് തന്നെ നമുക്ക് ബ്രേക്ക് ചെയ്യാം, പക്ഷേ കൂടുതൽ എനർജി റിലീസ് ചെയ്യും. എന്തുണ്ടാകും? പുതിയ ഇൻട്രാക്റ്റീവ് ഫോഴ്സ് ഉണ്ടാകും, സിൻസ് ഇറ്റ് ഈസ് സ്ട്രോങ്ങർ. അതുകൊണ്ട് the delta H will be negative, it will not be equal to 0. So enthalpy of mixing is not equal to 0. What about volume change during mixing? So a new interactive force which is stronger is formed. നേരത്തെ മോളിക്യൂൾസിന്റെ വീക്ക് ഇന്ററാക്റ്റീവ് ഫോഴ്സ് ആയതുകൊണ്ട് കുറച്ച് ദൂരെയായിരിക്കും. ഇപ്പോൾ ഒരു സ്ട്രോങ്ങർ ഇന്ററാക്റ്റീവ് ഫോഴ്സ് വന്നപ്പോൾ എന്ത് ചെയ്തു? The molecules are coming closer. Since the molecules are coming closer, the volume will decrease. So delta V mixing again will not be equal to 0. Delta V mixing will not be equal to 0. So that means all the characteristics which we need for an ideal solution is not shown by such solutions with a negative deviation. So these are the two different types of deviation from ideal behavior, that is solutions which show positive deviation and solutions which show negative deviation.